Here's the situation. You're working on an e-commerce app and your AI coding assistant just generated a migration to optimize your user lookups. The tests pass and it looks solid. But now you're going to run this against a production database with hundreds of thousands of users and millions of orders. Your test database has, 100 users. Your staging data is sanitized and it's months old. Neither is going to tell you if this migration will break on real data. It's also not going to catch that weird edge case from your old payment processor integration. Hey folks, I'm Matty, and I'm here with Jascha, who's one of our engineers here at Tiger Data, to show us fast, zero-copy forks, how to test this migration on a production-like database without any risk. Jascha, show us how it works.
Hey Matty, yeah, let's see what we're working with this time. So the first thing I will do is a Tiger service list command, which is part of our new CLI that we just launched, and you can see I have two services here. One is just a backup in case things go wrong today, and the other one is the actual demo shop that I want to show forks on. So I will actually connect to this database and show you what is inside of that. So we do a TigerDB connect with the ID, and this opens pSQL if you have it installed on your machine. And yeah, let's just list the tables here. You can see this is kind of like a typical demo e-commerce shop with orders, products, users, and we're even tracking some page views for analytics purposes. If we do a little look into the tables, so we do table users, let's do a limit of 5, just to show you what's inside of there. There's just some emails, some timestamps, some user IDs. Nothing too special about this. I think overall this database is like 2 or 3 gigabytes large, contains a few, like 500,000 users or something like that. So it's a decently sized production database. Probably would be a little larger if you have more metadata on the individual rows. Okay, let's go out of there. So now we want to usually create a migration and then we want to run this. Probably you would open a pull request and then it would eventually execute on your production database. The first thing that I am actually going to do is to fork this database. So what we do is Tiger service fork. Then I give it the ID of the service that we want to fork. And then in this case, I specify now, which starts a fork in the background of this database. And what really happens here is quite fascinating because this uses our new copy on write, or basically like zero copy fork of a database. So it uses a technology under the hood where the storage layer itself is not duplicating any bytes. It's using the same blocks underneath the hood for the original parent database and the fork database. And by the time this video comes out, there should be a blog from the storage folks about this exact technology, which you can probably find in the video description below. And I highly recommend to check that out because it's super fascinating what the folks built. Doesn't fork Postgres as a thing, like it doesn't like as a code base. It uses actually the storage abstraction itself to do this whole thing. And the only reason it takes a little bit is because it has to do a checkpoint on Postgres itself before actually doing the snapshot of the underlying storage layer, because otherwise the storage layer is not consistent with itself, which means you would have to do while replay and basically do some sort of like crash recovery, but this way it's just faster. And you can see it didn't even take, maybe 30-40 seconds, and we have a fork of the database. And now if I do TigerDB connect again.
So that's the whole database, all the tables, everything.
Exactly. So now we are connected to the new fork. You can see here we set the new service as a default service, so I'm connecting actually to the new one. And if I do table users limit 5, you will see the same 5 users as before, and everything we do here is completely isolated from the instance we had before.
So now we could break it, test migrations, whatever, but our production database stays untouched. All right, well let's try testing a migration with our fork maybe.
Sure, yeah, let's do that. So like any good engineer these days, I would probably not write the migration myself, but actually ask AI to do it. So let's open Claude Code and simply ask Claude, hey, can you give me a migration for my database and store it in migration.sql. Let's see what it comes up with. It's thinking very hard and comes up with an alter table statement to change one of the columns to a big integer. That sounds about right to me, so let's save that file. I think that makes sense. Probably the original user ID is a string, and as we just saw above, those are actually all integers, so it makes sense to change that type. Probably the index lookups will be a little bit faster, we use a little bit less storage. Why not? Okay, then let's close Claude code at this point. We could ask it to actually run the migration against the fork, but I think it makes more sense in this case to actually show how this works. I'm going to use the TigerDB connect command again, and as I just explained before, this actually uses psql under the hood, so any parameter that I put after the dash dash actually gets passed to psql. And anyone that has worked with psql knows that -1 makes a file run in one transaction. That means if the migration fails, this will roll back. That means I don't have to create yet another fork, which still takes 30 seconds, so we're saving a little bit here. And then I do -f and give it the migration SQL file to actually run it. And as I said also before, the default service right now is my fork, so I don't have to specify the ID. So let's see how that goes.
And
That's
away
a
we
table.
go.
And we run into an error. So we could look into now, like it says something about invalid input syntax and like try to fix the migration ourselves, but I'm actually just gonna open Claude again, do -- continue. In case you've never used that before, this basically opens the previous session again. So we have all the context from before. Claude knows about the migration that I just wrote. And I say, hey, I tried to run this migration, but I got an error. Can you fix this for me? So it's reading the migration SQL again, that's good. And now we get a fix for it. Let's quickly look at what it actually does. So it does a switch case here, and it creates a different column for legacy IDs. And I think the error that we had before, so there's like a user ID, in this case external user 1, that isn't actually an integer, so it doesn't fit into the big integer column. And that makes sense, like maybe you have an old integration with some payment provider or some external authentication provider, and I don't know, you're using string IDs for that case because they were using it internally. But maybe like 99% of your users actually do use like your internal IDs and are just numbers. And then having two columns for the lookups maybe makes sense because you still, the vast majority of your users would still benefit from the small performance improvements of big integer.
But we wouldn't catch this with test data because it's clean. It doesn't have this sort of legacy cruft from who knows what this old integration. So this is why if we had run it against a test database, we might not have seen this at all.
Yeah, it's a super typical case of where if you have a development database, you probably just have a script to create a bunch of test users and they're going to use your internal IDs. And of course you don't have the production data there. Why? Because why would you? Who takes care of that in such detail? Yeah. So it's a perfect use case of why forks are amazing. So we start the new migration SQL now, and I will run the same command as before against the same database again, and we'll see if this succeeds. I sure hope so, because otherwise I will complain to 𝗙𝗵𝗽𝗀 why it's not good at generating migrations. It looks great. Updating 500,000 users, creates an index on top, and we now know on the fork it worked, and we can safely deploy this to production, and no one will be paged in the middle of the night that a migration was partially applied and they have to fix production, which is completely down because, well, our migration just failed and the system is in an invalid state.
Which is no good for anybody. Nobody wants that. So that's awesome, but there's got to be some way that we can automate this a little bit more in our development process, because we don't want to depend on all of our developers always remembering to test locally against a fork when this comes in. We probably will remember, but we are human. We forget things sometimes. Is there some way we can automate this into our development process?
Yeah, of course. I mean, I just showed you that this is all available via our new CLI, so you can use the CLI to script any helper scripts that you would like to do, and then all your development team can, even for their own development purposes, create a fork, and everyone can work on production data locally. Or you just have a script to run migrations against, or whichever other kind of workflow you can imagine and can set up. And in CI/CD, you can of course also use the script, but I would actually recommend that you use a new GitHub Action, which makes this even a little bit easier if you are on GitHub, of course. You can see here in a minimal example, you basically just use the timescale fork service action, and then you specify the project ID and the service ID that you want to fork, and you give it an API key, which you can get via our console UI, and then it simply creates the fork for you. You can run your tests against it, and afterwards you can clean it up again. Actually, to clean it up again, there's a specific cleanup flag which you should just set to true, which then takes care that once the workflow has run to successfully to the end, or even if it fails, it ends up deleting the service again for you, and you don't have to worry about costs rising up or anything. Of course, if you want something else, like an ephemeral environment to test things, you can set this flag to false and delete it yourself afterwards.
Awesome. So, and then when we've got this action in here, this means that every migration, if we run this migration, it gets tested against production data before it can get merged. Everything's automated. It's beautiful. And before we wrap up on this, I see in the YAML there was a reference to forking strategies. What are the different forking strategies that we have available?
Yeah, that's a good point, actually. There's a little bit of a nuance here to which forking strategy you choose, and there's a little bit of a trade-off involved, so we make you choose and didn't default to anything specific. At the bottom of the README, you can actually see which of the forking strategies are available. And I think the main two that I usually use are now and last snapshot. And the only difference between the two really is that last snapshot is like super, super fast because it uses an existing snapshot. It doesn't have to wait for a Postgres checkpoint. It doesn't do anything. It just takes an existing snapshot. The only thing it needs to do is spin up the rest of the infrastructure, get the service up and running, and that's it. And if you specify now, it really ensures that you take a new snapshot basically and bring the service up to date on the moment that you ran the command, which sometimes is relevant because maybe you just merged a migration 5 minutes ago and this last snapshot is from 30 minutes ago. And then it's, yeah, of course, not ideal if you use the last snapshot, so you need now. But for a lot of workflows, last snapshot is actually enough, and it does speed up your CI/CD significantly. And I know as a developer, it's sometimes a pain. Like if your CI/CD runs for hours and hours on end, and the feedback loop is so slow, it's not a lot of fun. So in those cases, I do recommend to use last snapshot. And then the third option that we have is actually more for recovery purposes. So you can specify a timestamp specifically for point-in-time recovery. And this is a forking option that already existed on Timescale Cloud for a while, Tiger CLI actually now, where you can say, hey, something broke on Monday and users complained. So let's actually roll back our service and like create a fork from before when this feature was deployed or before our database broke. And we will actually create a fork at the exact timestamp that you specify. Yeah, for it's usually disaster recovery, but of course you can also use this to, I don't know, every Monday before the stock exchange opens, you fork your database because this is maybe the state that you want your database to be in, or yeah, whichever other workflow you can imagine.
I would say not so much in the GitHub workflow, but I could, putting my SRE hat on, I could imagine that this would be really useful if we were debugging an incident where we could say, hey, we had an incident happened at 3:47 yesterday. Let me create a fork from 2 minutes before that so I can replicate and reproduce the exact state it was in if I'm trying to bug and figure out what's going on. So just to recap, fast zero-copy database forks let you test against production data without production risk. This is great for catching edge cases and AI-generated migrations, automating your CI/CD with real data, and deploying on Fridays with confidence. Links to everything are in the description, the Tiger CLI, the GitHub Action, and the docs. So go break some databases safely.